Okay, so another classic related rates problem is this one, the ladder sliding away from a wall. And this is different from the previous problem because this is actually working with a 2D shape rather than a three-dimensional figure. So with a problem like, okay, first let's look at the problem. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is sliding away from the wall at a rate of 2 feet per second. How fast is the top moving down the wall when its base is 7 feet? So with a problem like this, it can be hard to visualize, so I like to draw a diagram before I even start with the math. So here we have a wall, and obviously we have the ground. And the problem says that we have a ladder that is 25 feet long and leaning against the wall. So let's draw that. Okay, this is the ladder and it is 25 feet long. And already we can see that we are going to be working with a right triangle. And okay, let's put some labels first. This will be A, and this will be B, and the ladder will be C. Next thing we should do is label what we do know already. So we do know that C is 25 feet. We know that A, the base, is sliding away from the wall at a rate of 2 feet per second. So dA dt, the rate of change of A in respects to time, is 2 feet per second. And lastly, we know that A, the base, is 7 feet. Now that we have this written down, we can write down the Pythagorean theorem, which relates all of these variables together. So, as you know, the Pythagorean theorem is a squared plus b squared equals c squared. And what do we already know? We already know that c equals 25, so we can just plug that in. 25 squared equals a squared plus b squared. Next, we can take the derivative of what we have here. Take the derivative always in respects to time because we are looking at a rate of change over time, so d dt. Taking the derivative, we have 2a, but don't forget the dA dt plus 2b dB dt plus 0. Since this is a constant with no variable, the derivative of that is just 0. Alright, now it's the easy part. We can simply plug what we know in. 2a equals 7, dA dt equals 2 plus, oh, okay, so now we have run into a bit of an issue. So we are looking for a dB dt. We are looking at how fast the top is moving down the wall. So how fast is this sliding down? That's what we're looking for. So how do we find B? Well, we can easily find it with the Pythagorean theorem. You could have done this first, but alright. So 7 squared plus b squared equals 25 squared. Once you do the math, b equals 24. B equals 24. So we can plug 24 in, and once you do that, we know that dB dt equals 7 over 12 feet per second. This is the value that we get. When you look at the original question, you kind of have to use intuition here. It is sliding down, and it's all kind of relative, but if you want to use logic, since it is sliding down, the answer would be negative. But of course, this is like a relative thing. If you presume that up would be negative and down would be positive, then the answer would be negative, positive. So you're just gonna have to look at the question for context. And if it's unclear, you can simply say 7/12 feet per second downwards. And that would be the most safe answer, I would say. So yeah, thank you. Good luck.